page, question number 2. A radioactive isotope is decaying at a rate of 18% every hour. Currently, there are 100 grams of the substance. Okay. Write an equation that will represent the number of grams present after n hours. So I'm going to say right now is hour 0, and there's 100 grams of it, and it's going away. Big idea is I think we know how to build the multiplier pretty easily if something was growing. So if I told you it was growing by 18%, the multiplier would be 1.18, right? It would be what we would have. If I'm decreasing or decaying at a rate of 18%, that means that every single hour that goes by, right, I'm losing 18%. But the important thing is, because I'm starting with the 100 grams that I have, the important thing is, well, what am I getting to keep, right? So if 18% is going away, what I'm getting to keep is 1 minus 0.18, which is 82%. So the important thing here is that my multiplier for an 18% decay is 0.82. So let's think about this here. I've got 100 grams. I'm going to just use Y. Y is 100 grams that I'm starting with. And every single hour that goes by, I'm getting to keep 82% of what I have. Translation, I'm losing 18%, and I'm going to raise that to the x power. And it says how much will be left after 12 hours. So what I'm going to do here is I'm just going to take the number 12. I'm going to say x is 12, and I'm going to put it into that formula. So I'm picking up my calculator, and I'm going 100, 100 times 0.82 raised to the 12th power. And when I do that, I get that there would be 9.24 grams, right? I get 9.24 grams would remain after that much time. So because I chronically make mistakes, and I like to try and think of ways to double check myself, I'm going to do it a different way. I'm going to start at 100, press enter, and now I'm going to just go times 0.82. So that 100 is hour 0, and now I'm just going to press the button and count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And guess what? On my calculator, I got the same 9.24 grams. So feeling pretty good about that. Next, it says, when will there only be 1 gram left? So I could keep pressing. My fear there is that as I do that, I lose track of how many times I've pressed it. Let me try it. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, 23 is 1.04 grams, and 24 is 24 is point what? It's 0.82 grams, 0.82. Now, again, that was me counting and pressing the button, which is I'm a little nervous about. So I'm going to take the approach now where I'm going to use the button on my calculator that says table, right? There's that little round button that says table, TABLE. And as soon as I press that button on my TI 83 plus calculator, I'm going to clear the function from the last problem, and I'm going to type the following. I'm going to type 100 and then times 0.82 raised to the power of x, enter. And this is going to start at, I'm going to make it start at 0 and increase by 1. Okay, so when I do this, I can see everything that I was talking about is on here. In fact, if I go down in this table to hour 12, 8, 9, 11, 12, yeah, it's exactly 9.24, which is what I thought it would be, 9.24 grams. And then I'm going to go down to hour 23. It's not even it's almost at a day, huh? So hour 23, I've got, 1.04 grams. And then at hour 24, I'm at 0.85 grams. So it says, when will there be only 1 gram left. And I'm just going to say the following. Um, I'm going to say between hour 23 and 24, somewhere in between those 2 hours, I'm going to go from having 1.04 grams to 0.82 grams. And I'm not going to think about fractional hours or minutes. I'm just going to leave my answer at that, somewhere between those two. That's all that I'm going to, I'll hit that point. All right, next, consider the following equation. 4x minus 3 equals negative 2x minus 9. And then it says solve for x. Okay. I think to solve for x, I'm going to add 2x to both sides. So I get 6x minus 3 is equal to negative 9. 9, 10, 11, 12. I add 12, so I get that 6x is 9. Oh, if I add 3, I'm going to get negative 6. And then I get that x is the number negative 1. Okay, so I got x is negative 1. And then it says, how do you know your solution is correct? Explain completely. Well, I don't know yet, but I suspect I will know if the following is true. So if I take negative 1, which is my value of x, and I plug it into both sides of this equation, what I want to see is that both sides of this become the same. So on the left-hand side, I've got 4 times negative 1 minus 3. And on the right-hand side, I've got negative 2 times negative 1 minus 9. That left-hand side is going to be negative 4 minus 3, which is negative 7. The right-hand side is going to be positive 2 minus 9, 7, 8, which is negative 7, right? Positive 2 minus 9 is negative 7. So the reason why this is a solution, negative 1 is the solution because it makes both sides equal, right? Namely, equal to negative 7, right? So because they are both, right, they are both negative 7 when I plug in x is 1. That's exactly what I'm claiming. I'm claiming when x is negative 1, the left-hand side and the right-hand side are the same. Okay, next, it says graph the following system of equations. Really? Y equals 4x minus 3. Okay, so I got a y-intercept at negative 3 and a slope of up 4. I can't go up 4. Let me do this. I'll go down 4 and then backwards 1. So I'll go down 1, 2, 3, 4, and backwards 1. Okay. Can I do that again? 1, 2, 3, 4, and backwards 1. All right, so that's my slope of positive 4. On this thing, if I draw a line, it becomes straight if I'm close. And then I think I can grab this line and I can, oh, I erased it. I think I can grab this line and extend it. Oops. So let me grab the line and I'll just pull this up like this way. Okay. I think this is good. I like it. And it's definitely hitting the points that I can see. If I go, yeah, I'm close to my y-intercept at negative 3. I'm a little disappointed in the line. Maybe let me try this again. Can I change the? No, I can't rotate it. So I'm just going to leave that line there. Okay, I'm going to call that the line y equals 4x minus 3. The next line is y equals negative 2x and then minus 9. So I'm going through negative 9. I'll use green here. I'm going through negative 9. Got it. And my slope is down 2 over 1. Down 2 over 1. Down 2 over 1. So let me try and draw a better line this time. So here's a line. Okay. And then same thing, I'm going to grab that line and extend it. This is just, you would not do it this way. You've got a ruler. Okay. I've done something wrong. I know I have to have done something wrong. I did a slope of negative 1/2, right? I know that I did something wrong because I know that these lines are supposed to intersect when x is 1 based on this first question. So, man, I'm glad I caught that early. So I did down 1 over 2 but this has a slope of down 2 over 1. So its slope is supposed to be down 2 over. This is supposed to be a point, right? So if I was to draw this line, okay, and then extend this line, much steeper this time. Oh, I can see. I can see. I can see. I can see. Uh-huh. Uh-huh. This right here, I can see x is 1 when these two lines come together, right? X is 1 when these two lines come together. All right, so this question says, how do parts A and B relate? Explain completely. Well, the thing is that in part A, right, I was asked to solve the equation that you get when you set y from this first equation equal to y from the second equation. And when I solved that, right, what happened was, well, there's no y because there's no more a y in that equation. It's just something with x equals something with x. And I solved it and I got that x was the number -1, right? So I guess in part A, right, in part A, I, let me say this. When I solved part A, I found the value of x that made both y values the same. Oh, in fact, when I plugged it in, when I plugged it in, right, when I plugged in that x is 1, remember what I got? I got that y was -7 in both of those. So not only did I get that, right, but I got, I actually, because I plugged it in, it's like, what is the y that's equal? When I plugged in the x here to check my work, right, to check that this was really correct, I got -7. And I can see the benefit of that here now because that's actually the y value for the point. So when I solved part A, I found the value of x that made both y values the same. Which is 7. Oh no, -7, which is -7, right? Dude, that's totally what that is. Yeah, so solving that top equation and getting x, right? That gave me the x value for the intersection of the left and the right hand side. But then when I checked it and I plugged in the x to both, right? And I saw that both sides, right? To check this equation, when I check it, I said, hey, both of those become -7, right? That's exactly what's happening here, right? On the red line, there are lots of different x values I can feed it, right? But it's only when I feed it -1 that I get -7. And for the green line, there's lots of different values I can feed it, but only when I feed it -1 does it give me -7. It turns out that that's the point, right, where these two lines intersect. That was fun. I'm going to take a quick break here, but you won't notice that because I'm just going to, that's it for this video.